Good afternoon, class. Today we're going to be looking at circles, and I need to do some writing first before we look at any of the problems. There's an algebraic approach to circles and a geometric approach. I'm assuming you saw the geometric approach to circles in high school or some other class. We're going to be taking an algebraic approach, but we assume that you're familiar with the geometry of a circle. You know what a circle looks like. You know that there's a point right in the middle that's called the center, and that the distance from the center to any point on the outer edge, what's that called? The radius, okay. Since we're taking an algebraic approach to circles, algebra, that means you need some variables. The variables we'll use to represent the center of a circle is the ordered pair HK. The radius, we'll just use the lowercase letter r. We have something called center radius form for the equation of a circle. You couldn't do that a little quieter, could you, Tony? Center radius form of a circle. Center radius form of a circle is derived from the distance formula using a point on the circle xy and the coordinates of the center HK, and then solving for r. We'd get rid of the square root then, I should have said. We'll get rid of the square root, and by squaring both sides, that's why we get this form. It's x minus the x coordinate of the center squared plus y minus the y coordinate of the center squared is equal to the radius squared. These are no good. Realize there's a lot of letters here, but the only variables you have are x and y. They're representing an arbitrary point on the edge of that circle. X is a variable, and y is a variable. H, K, and R are all numbers. When we look at problem number 1, it says to find the center radius form of the equation of a circle with the center at the origin, HK, and radius 16. I better write this down. They tell us the center is at the origin 0, 0, and they tell us that the radius is 16. We want to write an equation of the circle and then graph the circle. They have a really nice graphing tool for circles. When I look at the center, I know that the first number is acting as my x value of the center, h, and I know the second number is my y value of the center, k. To find the center radius form, you're going to have to plug in to that center radius form that I gave you. Notice I'm leaving the 3 number spots empty. You help me out. It's x minus h. What number am I going to write here in place of the letter h? 0, the first 0. What number will I write here in place of the letter k? It's the second 0. What number is going to be squared on the right-hand side? 16. Now, in most cases, you can't really do much to simplify, or you don't want to do much to simplify center radius form, but here, x minus 0, we know that that's the same thing just as x. So we have an x squared plus y minus 0. We know that's the same thing as y squared. And 16 times 16 is 256. You're squaring, not taking the square root. When I saw that 16 for a moment, I had a desire to take the square root.
Put a 4 there.
No. Here's my center radius form. Have we been typing subscripts so far this semester? I mean, exponents? Have you? No? Okay, there's an exponent hot button, but if you hover over it, it says superscript instead of exponent. So you have x. You see that third box there? It has a little gray box and then a blue box in the exponent position. That's where you use your exponent. Then you have to get out of that exponent position. You don't want the plus up there. So right arrow or use your mouse to click. Get out of the exponent position before you put your equals. That is not what we want. You don't want that equals 256 in the exponent position. Either right arrow like I do or click with your mouse. If you're using a touch screen, touch the screen. Any questions there? Now they want us to graph. To draw the graph of a circle, you need to know the center and you need another point. And you find the other point by using the radius. But I don't think that...
oh my God.
Oh.
Wow.
So much for a good first problem.
Hopefully your number will be smaller than 16 as
hopefully.
a radius. Misty, your radius will probably be 59 or something like that. Okay. Oh gosh. So I'm going to choose the
No, expand the yellow box. Now it says choose the tool. There's only one tool there that looks like a circle. Which one is it?
The one with the circle.
The one with the circle
Okay.
there. And so it says plot the center. The first thing you do is plot the center. And the center is at 0, 0.
Oh my gosh.
Then it says plot another point. Well, that's where you use the radius. You can either move up, down, left, or right 16 units.
If I can shout in something as you're shouting, Tim.
You need to conserve your voice because when my voice is gone from the shouting, you're going to take over.
Oh, wow.
Does that do it? Notice when he's moving 16 units up, it was also moving 16 units down, left, and right. So it doesn't matter which direction you move. Either up, down, left, or right. You plot the center, then whatever the radius is, up, down, left, or right to get the second point. If he were going up, what number should he be at on the y-axis? 16, is that where he wanted to be? Look at that ordered pair in the yellow box. Yep, 0, 16.
I don't ever recall having such a big
Number.
radius like that. I noticed
Okay.
that. Oh, wow. Okay, I'll say checking answer.
Looking back last semester, the radius was 5 on the first problem.
I made it. So
Okay. Number 2. Same instructions, but they've given us a different center. The center is at the ordered pair -1, +1, and the radius is 4. Well, let's write out what we know. We know we're going to have parentheses and an x minus, plus, we're going to have a y minus, the x, the y. We have 3 numbers that we're going to have to fill in. What letter is -1? I'm going to label this ordered pair. What letter am I going to write here above -1? Not X.
Well, yeah, it is an
It's
X
the X
value.
coordinate, but it's the H.
H.
We're going to use H for the X coordinate in the center. And what am I going to write here? K. So I have a -1, X minus a -1. We'll clean that up in a moment. We have a Y minus. What am I writing here? At +1. What number's being squared? 4. I'm not sure why they're using perfect squares in every one of these. X minus a negative, that becomes an X plus 1. And that'll stay a Y minus 1. And what have we got on the right-hand side? 16. Any questions there? What do we use this equation for when we draw? What do we use to graph a circle? Am I going to use this equation? They could have asked us to graph the circle first and then write the equation. They gave us everything we needed to draw the graph.
That's all you need for a circle. You've got to graph it. You got to know the center. You got to know the radius.
Well, if they would give you another point, then great, but they're not going to do that. If they give you a point on the circle, then you don't need to know the radius. Just go to that other point. But the problems, they give you the center, the radius. You use the radius to find that secondary point.
In public school, if you ever had to buy a compass for drawing circles, you would take the compass, the sharp point, put it down at the center, then move over 4 units, spin it around. That's what we're doing with this digital. Oh, wait, I got to put this. While we're talking about graphing, I got to type in the answer first.
Left parentheses, X plus 1, right parentheses, quantity squared, get out of the exponent, plus left parentheses, Y minus 1, right parentheses, quantity squared. Oh, and the shift up arrow, if you want to use the little those keystrokes to get to the exponent, rather than go into your the hot button, it's shift up arrow. Shift up arrow will put you into that exponent position.
Okay.
But if you're trying to type an exponent and there's not an exponent hot button down there, you're trying to type something that you shouldn't be typing. Okay? Why do I use the keystrokes? It's quicker than having to grab the mouse and click on that thing.
Oh, this is a better first example.
It would have been. I mean, it is. You're
See,
right.
it's like graph looks so much cleaner. I click circle. Now plot the center. If you were doing this with an old-fashioned compass, I remember we'd buy these metal compasses as children.
With the sharp points, I'll be honest, I still have one of mine from high school in my desk drawer, in case I need a weapon. That sharp, rusty point, I figure that's a pretty good weapon.
People poking us, or I'd poke them and stuff.
God, we were bad
children.
We could have. I know. Yeah. I think they outlawed the. I hope they outlawed the things.
Okay.
I know they outlawed the clackers. Remember the clackers?
Yeah, there were these little games, and people killed themselves with them.
Hitting themselves on the head.
Yeah. Okay. Anyway. I plot the center. Now I need to move over 4 units.
It doesn't matter whether you go up, down, left, or right.
I think I'm going to move up. 1, 2, 3, 4. So I started at -1, 1. I moved up 4, and the yellow rectangle says I'm at -1, 5. Is that correct? Is that where I should be if I moved up 5? Up 4. And notice, now you can easily count. When I moved up 4, it also moved 1, 2, 3, right 4, down 4, and left 4.
Once again, when we were in school, this would have been, I'm sure the Pentagon or something had stuff this fancy, but it would have been science fiction for us.
Oh, how many of these do we have? Okay, here's another one. Number 3. Find the center radius form of the equation with a center of 5, -4, and a radius of 5. Have you written it down?
Mm-hmm.
You sure have.
Well, for the center radius form, we know it's going to be x minus y minus
hopefully if someone asked you right now, what are you doing, you would be able to say, I'm writing the equation of a circle. Have we done anything with circles this semester before today? No.
Mm-hmm.
This is new stuff.
Mm-hmm. What number is acting like my letter H? 5. Which 5? The 5 on the right or the 5 on the left? 5 on the right, okay.
But no, the 5 on the left.
No, the 5 on the left. Okay.
Y'all answered
So,
right,
yeah.
you said wrong.
I was supposed to be left-handed, but I was taught to be right-handed, okay? As a result, I still confuse left and right to this day.
Because we were mirror twins.
We were the rarest form of identical twins, you're right. Okay, what letter am I going to label this -4? Okay, so y'all tell me what I'm going to put. Here, 5. Here, -4, I agree. Here,
That's
oh, it's this 5 right there.
and how long
That 5 there. And that first binomial x minus 5 we're going to leave alone. What am I going to do with that second binomial, y minus a -4? Change it to a positive. And 5 squared is 25. I wonder if you left it as a y minus a -4, y'all think that MyLab would take that as a correct answer?
I have never actually punched in
And
that.
I don't ever recall doing that either. Why don't you?
Okay. I'm just going to see. Parentheses.
X minus 5, right parentheses, quantity squared, get out of the exponent before you type the plus, left parentheses, y minus a -4. I'm just curious whether they're going to take it. Right parentheses, quantity squared, get out of the exponent before you write equals 25. What do y'all think? Y'all think it's going to take it?
I'm
No?
just really curious.
No, there's a problem.
Oh, your answer is equal to the correct answer. It's not in the correct form. There's no instructions that say you can't write minus and negative.
No.
Okay,
But still, change that minus and negative, so now we know that answer. No, MyLab will not accept it.
Okay.
And now we're ready to draw the graph. Once again, you don't use the equation. You need the center and the radius to draw the graph. So they could have asked us to draw the graph before we even wrote the equation, but they didn't. We go to this. We click the circle tool. Then we go to the center, 5 -4.
Gosh. Oh, wow. 5. Oh, no. Am I at 5 -4?
Is it 5 -4? Yes. So he clicks there.
And now I got to move 5 units over. If I move 5, I'm going to the left.
Where is he going to wind up if he moves 5 units to the left? That's easy to count. Isn't he going to wind up on the y-axis? That's what I'd do. I'd move 5 units to the left. You wind up on the y-axis. You'd get the same circle if you moved up, down, left, or right. But for counting purposes, I think just moving back to the y-axis would be easiest. Check the answer. We need to make some observations here. Switch back to my paper. Look at center radius form. When you look at center radius form, I notice something inside the parentheses. the numbers, the things I see inside those parentheses are exactly the opposite of the center. Here I see a -5, but what's the x-coordinate of the center? A +5. Here I see a +4. What's the y-coordinate of the center, though? A -4. What you see inside the parentheses will be exactly the opposite of the actual center. What about this number here? If you wanted to go back to the radius, what do you do to go from this number back to the radius?
You don't square it, you
Square root it. You're undoing the square. They're going to start giving you center radius form, and you have to go back to the center radius. Change sign, take the square root. And I'm going to make a note of that here. And hopefully you see why that's the case. The formula has a minus. And so if the number is positive, you're going to see a negative, a -5. If the number you plugged in is negative, because of the negative in the formula, negative, it becomes a positive. So here, I'll say, you have to change sign to go back to the, change sign, and to go from the number on the right back to the radius, you'll take the square root.
Want to mention this thing now that I gave?
Why don't you just pull it up on the, I have it downloaded on there.
Oh, I think someone came in and I didn't give them one. I walked around handing.
Does anyone not have the circles handout that was passed out?
Yes. For some reason I thought someone walked in and I didn't give it to them. Okay, well, if you didn't get one, then they're right here. You sign in your name in the roll sheet.
Let's look at what this handout says. The equation of a circle centered at 0, 0. Well, we saw that on problem number 1. The x minus 0 and the y minus 0 just became x squared and y squared. So that's nothing new. If it's at HK, there's center radius form. Okay, I told you that. Now to find the center and radius of a circle when the center radius form is given, change the sign on the number paired in the parentheses paired with the x. I told you that. That's what we were just talking about. Change the sign on the number in the parentheses paired with y. I told you that. And to find the radius, going backwards to undo the squaring, you take the square root of the number on the right-hand side. And let's see.
Way back before we had our YouTube videos, we had leaflets.
This is one of the few leaflets that survived the switch, okay?
Yeah, but if the student was absent, what did we have to give them to try to catch up? Well, here's your leaflet. That's the equivalent. This thing used to be the equivalent of a YouTube video.
Okay, so we want to know the center. Well, you got to change the sign. You see a -2, the x-coordinate of the center is a +2. A +5 with y, that means the y-coordinate is a -5. And what do we do to 49 to go back to the radius? Take the square root. Here, there's nothing, the second example, there's nothing being added or subtracted from x, so what do we assume the x-coordinate of the center is? 0. But here we have a -8 paired with y, so the y-coordinate is +8. And the radius, we're going from 36, you take the square root to get a 6. Let's look at number 6 in our homework now. 4 and 5 are just like number 3. Find the center radius form and then draw it. So number 6, though, is different. All they've asked us to do is graph the circle. They gave us an equation. Let me write the equation down. X minus 1 quantity squared plus y plus 4 quantity squared is equal to 16.
You know what, Tim? You can stop the quantity to conserve your voice. Just x minus 1 squared. What do you think?
No, I'm not going to do that.
Okay.
I'm not going to.
In order to graph a circle, we've got to know not that equation, but what? What have we been using to graph these?
The center and the radius. When you look at this center radius form, you should be able to tell me the center and the radius.
A little phrase that I'll be saying one day when I'm old and out of my mind is change the sign,
I won't put in the change sign, take the square root. I'll be in that nursing home and people will be wondering, what is that old man saying as I'm sitting in my rocking chair? Change sign, take the square root. And so
the worst thing will be second sign is plus, so 2 of the first sign. Second sign is minus, so 1 of each sign. And they'll be scared of me. So,
the employees will wonder, what is he must have been a spy, and these are codes that he used during his life as an international spy, a man of intrigue. Y'all tell me the center. Okay.
Change the sign.
I'm going to have AI analyze this video later just to see what they make of what we've been saying here now. They'll probably say it was brave. The presenters were bravely unbalanced men who segued into nonsense frequently. I'm even telling AI what to say, I guess.
Okay.
Maybe I won't ask AI to analyze.
What's the y coordinate of the center?
Negative. Okay, change sign. Now the square root. The radius. Okay, you take the square root of that number there, which is 4. Change sign, take the square root, and that's all you need to know. You can draw the graph now. Let's go to they don't want you to type in the center of radius. You're only using it to draw the graph. You click the circle tool. You plot the center. The center is 1, -4. And the radius is 4. It seems like they're having the radius show up as coordinates in the center because they know that makes it easier for graphing. If he moves up 4 units, he's going to wind back at the x-axis. So I think they're doing that deliberately, the programmers, to try to make it easier for you to do that counting.
Especially on MISTI, where the radius will be 57.
They will not give you an irrational radius because it'd be impossible to count that distance, okay? The square root of 57. On paper, you could approximate.
57, she would have 57 squared if the radius is 57.
Yeah, you're right. Okay.
Let's do another one of these.
Okay.
They're given that form with the parentheses. That's the nice form.
Unfortunately, they're not going to keep giving us this center radius form. In a little bit, someone's going to decide to be smart and foil out all of this stuff. And then it's not going to be easy to find the center and radius. You should be appreciating center radius form while you have it. Because in this case, then it's easy to find the center and the radius. Y'all tell me the center and the radius. I'll start with the center. Here, I heard a 1 and a -1. -1, remember, change sign. Here,
change the sign, square.
-2. And then what do we do over here? Square root, that 9, to get a radius of 3. But they're not asking, you don't have to type that stuff in.
Then why do you find it?
Because that's the information you need in order to draw the graph.
Even if you were doing it on paper with a compass, you've got to know where to put the sharp point.
And then how far to stretch the compass out. I should go find that compass. I suspect that they think it's a deadly weapon and I'd be in trouble. Yeah.
I remember years, way before y'all were born, there was this colleague of ours that got into a habit of always coming to our office before class. And one day he saw my chalkboard compass.
You put the rubber part at the center and you stretch it out and draw the perfect compass.
The perfect circle on a chalkboard. And I remember, the man said, oh, he'd love to have that to give to his son. And I said, well, I'll give it to you
if.
you leave right now and not come back. And he said, okay, and he took it and left. The next day he was at our office, and I was like, oh, no.
You got our compass, our
When I
chalkboard
said
compass.
leave and not come back, I mean leave and not come back ever. And he laughed.
Yeah, we lost our compass. Good job, Tony.
Yeah, but no, he did leave, and he finally figured out I wasn't completely joking. And I said, leave and don't come back.
So you counted 3 units upward.
And that would be the same as 3 units to the right.
Either way, you'll get the same circle. It sure is nice when you have those small
Radius.
small radius values. Okay.
It's about to get bad.
It's about to get bad. Okay, look at that and tell me the center and radius. Don't write this down yet. Don't write it down yet.
Do a little discussion.
There's a lot of discussion going on.
I said a little to try to make it.
Don't write this down yet. Tell me the center and radius. Can you just look there and easily determine the center and radius? Is this thing in center radius form? That's the problem. We're going to have to take equations that have been expanded through foiling and rewrite them so that they're in center radius form. I think I'll just look at, I think I'm going to take number, what do I want to do? I guess I'll use number 6, okay? I want y'all to consider this equation.
Are you going to foil
I think
that out?
I better come up here.
Number 7 instead.
Because the signs are all positive.
Okay. Yeah. I mean, then you get out to recopy it. But okay.
Okay, you're right. We'll do this number 7. We're going to work with number 7. Although this has nothing to do with your answer. Of course I'm going to recopy it, Tony.
I thought you were just... What he's about to do is foil out this part and foil out that.
You know, I guess in our fervor, we gave away the big question. How do you square a binomial? It's not just x squared plus 1 squared. If it's a sum or difference, to square it, you have to write it twice, x plus 1 times x plus 1, plus, that plus right here is the plus I'm writing right there. And then for y plus 2 squared, you have to write it twice. Y plus 2 times y plus 2 is equal to 9. And the way you get a problem like that, number 8, someone did just this. They went through and foiled all this stuff out. Foiling out the x plus 1 times x plus 1. We get first, outer, x times 1 is 1x, plus inner, 1 times x is 1x, plus last, wait a minute, 1 times 1 is 1, okay. Oh, goodness. Any future teachers in here? This is what you do. You wait for the student that always answers correctly, and when she messes up that one time, you pounce. That's a good teaching strategy. That's a bad teaching strategy.
He's joking about that. Okay, so now foil out the y plus 2 times y plus 2.
I'm going to let y'all call that out so I can conserve my voice. Y squared, outer, plus 2y, that's plus inner, another 2y, plus last, 4. And you know what I'm going to do? I think I'm going to take this 9 and move it over to make it a minus 9 equals 0.
Is that how it's number 8 is written?
No, they have the number on the right. Well, still. Now I'm going to, I think I'll combine the like terms. We have an x plus x. So we have an x squared plus 1x plus 1x is 2x plus 1. And then 2y plus 2y, that's a 4y plus 4. And we still have that minus 9 stuck on there.
I guess when you say combined like terms, I think...
I know,
they were
I mean
wanting to
combine variable terms, okay? Y'all are wanting to combine the 1, 4, and negative 9. We'll do that in the next step. I do have a reason for doing this. X squared plus 2x plus 1. Those first three terms came from the x plus 1 quantity squared. Y squared plus 4y plus 4 came from the y plus 2 times y plus 2. That minus 9, we just move the constant over. Now, we're going to write the terms in descending order, alphabetically, based on powers, and combine any remaining like terms. So we'll put the square terms first. We'll put an x squared plus a y squared. Then we have a plus a 2x and a plus a 4y. 1 plus 4, that's 5, minus 9, 5 minus 9 will give me a minus 4 is equal to 0. I guess you could have the 4 over on the right-hand side if you wanted to. This form here, where the parentheses have been removed and the like terms have been combined, is called standard or expanded form of a circle.
I like expanded.
I do too.
That means someone went through and
expanded those binomials. And they may have thought they were doing you a favor, but with the exception of implicit differentiation. If you were differentiating this, if you had an expression that you were trying to differentiate implicitly, then I can see them expanding this. That would be easier. But otherwise, I can't really think of a time why you would want to take center radius form and write it in expanded form.
But you did.
But I did.
We're about to start going backwards.
So when an equation is written like this expanded form, there's really nothing nice about it. You can't look and tell what the center is easily. You certainly can't look and determine the radius by taking the square root of a number.
And you can't take the center. I mean,
you can't determine the center easily. We're going to have to take this expanded form. We're going to go backwards. From expanded form, we have to go to center radius form. Now, things like x squared plus 2x plus 1, that the trinomials that factor as a binomial squared are called perfect square trinomials. Likewise, y squared plus 4y plus 4, that's a perfect square trinomial. It factors as a binomial square. Here we have an x squared plus 2x, but in the final answer we don't have that plus 1 to go back and factor it. Likewise, here we have a y squared plus 4y. Well, the perfect square trinomial had a plus 4. We don't have a plus 4 there. We have a minus 4, but not a plus 4. We're going to have to go back, taking what we have and introducing a perfect square to create the perfect square trinomials. In order to do that, you need to notice some patterns regarding perfect square trinomials. Here's an example of a perfect square trinomial.
So we're going to review a little factoring right now. Is that right?
Yes. Let's say x squared plus 10x plus 25. I claim that's a perfect square trinomial. Now, to be a perfect square trinomial, that last number there must be a perfect square. It makes sense since it's a perfect square trinomial. We could factor this. If we were going to write it and factor it by trial and error, x squared would be x times x. What signs would we have? A positive.
Second sign is plus, so 2 of the first sign.
And for 25, it's either 1 times 25 or 5 times 5. Remember, a simple trinomial That number, the pair you choose has to add up to give you what? 10. So what are you going to use? 1 times 25 or 5 times 5? 5 times 5. A perfect square trinomial factors as a binomial times itself. So we could rewrite that as just x plus 5 quantity squared. Here's another example of a perfect square trinomial. X squared minus 8x plus 16.
Hey, observation. In order to get the exact same thing in both sets of parentheses, this second symbol must be what?
Has to be positive. That's right.
If it had been a minus, then it would be a plus and a minus.
And you would have the same thing inside the parentheses.
So a perfect square trinomial must end with plus
a number.
Square.
Plus a perfect square. That's good. Okay. Let's factor this. X squared, that's easy enough. What are we going to use as our signs? Okay, the last sign's a plus, so you have 2 of the first sign, so a minus minus. 16, 1 times 16, 2 times 8, or 4 times 4? 4, yeah. Well, if it's a perfect square trinomial, you got to use the square root of that number there, 4 times 4, and sure enough, if you FOIL it back out, you'll get that x squared minus 8x plus 16. We can write that as x minus 4 quantity squared. Now, when you look at the expansion, all we have is x squared plus 2x, or y squared plus 4x. You're only going to have the variable terms in the expansion. You're going to have to figure out what is that perfect square that you add on there to create that perfect square trinomial. You're going to have to be looking at perfect square, trying to figure out what perfect square you add on to generate the perfect square trinomials. So let's see if y'all think y'all are ready for this. Let's say x squared plus 6x plus what number? What number would I need there for this to be a perfect square trinomial?
It's got to be a perfect square. What are the perfect squares?
Let's see.
1, 4, 9, 16, 25, 36, 49.
What are we doing? How are we going from 10 to 25? What do we do to go from 10 to 25? I think that's the best example. I'll get us started. We're working with the number 10. We're going to do 2 operations to get it to 25. What do we have to do?
I'll get started. Divide by 2.
Let's say, take that unsquared variable coefficient, divide it by 2, that gives you a 5. Well, you don't want to add a 5 there. 5 isn't a perfect square. What else do you have to do? Square it. 5 squared is 25. That's where we got the 25. Apply that logic here. What number am I going to put in the blank? You have to do 2 things to that number 6. What are they? Divide it by 2. 6 divided by 2 is 3. And then 3 squared becomes a 9. So there's your perfect square trinomial.
What you just did is something called completing the square.
What we've just done is completed the square. By figuring out that number, we've created a perfect square trinomial. Completing the square is a technique used to create perfect square trinomials. How is this going to factor? I'm going to skip this stage. I'm going straight to the square stage. I agree. X plus 3. It'll be variable, and then whatever that first sign is, in this case plus, and it's either, you can think of either half of that number or the square root of this number. I go variable, sign, half of that number. That's another one of those things I've said so many times over the past 38 years. I'll just be sitting in the nursing home in my rocking chair. I hope they let me have a rocking chair. Surely they will. And I'll be saying, variable sign, half of that number, variable sign, half of that number. And look at that, that works here. Variable x, sign, a minus, half of 8 was 4. Y'all help me create another perfect square. Let's say x squared minus 12x plus what? What number would I need to put there for this to be a perfect square? There's only one number you can put there to mate with x squared minus 12x so that it will factor as a binomial square. What number would I put there? Oh, I agree. Half of 12 is 6. You say, well, that's a negative 12. But remember, what am I going to do? Once I take half of that number, what do I do? Square it, so it becomes positive anyway. So I don't even take into account that minus right now. I just say half of 12 is 6. 6 squared is 36. So I put the plus 36 there. How will it factor? X minus, I didn't hear you? 6. That's one of the problems. I'm talking so loud that I can't hear the quiet stuff. Variable sign, half of that number.
What about x squared minus 2x?
Yeah, what about x squared minus 2x? What number would I need there? To create a perfect square, what would I use?
Half of 2.
Half of 2 is 1.
1 squared is...
So we add the 1, and how will that factor? X minus 1 quantity squared.
Oh, I'm hoping that's what you had on that.
I think it is. That looks familiar to me. X squared minus 2x plus 1. It was a plus, okay? So if that had been a plus there, that would have been a plus. We've just now justified how x squared plus 2x plus 1 goes back to being just x plus 1 quantity squared. We're going to have to do that for the x terms, and we're going to have to do it for the y terms. That means we're going to have to be adding in numbers to create those perfect squares. When working with an equation, if you add 1 pound to one side of the weight, you have to add 1 pound to the other side. So the numbers that you're introducing, you'll have to be adding them to both sides of the equation. You'll see what I mean in a moment.
Okay,
Let's go through...
I think we might be timed out.
Uh-oh.
Okay. I'm clicking just...
I'm going to do number 8, and then we'll look at the little recipe that we have on that handout. But I want to look at, just logic my way through number 8, and then we'll look at the little recipe we have. X squared plus y squared minus 12x plus 4y is equal to 24.
This color might make it.
Okay, I see x squared minus 12x. There's not a number that I add in there, so I'm going to write written there for me. So I'm going to go x squared minus 12x, and then I'm going to say plus, skip a space. I'm going to add a number in there to create a perfect square in a moment. Now the y terms. We have y squared plus 4y plus, skip a space. If that 24 had been over on the left, I would have moved it over to the right, okay? But fortunately, they already have it on the right where we want it. We have to create a perfect square trinomial. What number am I going to put in that first blank? X squared minus 12x plus what? Okay, remember 12 divided by 2 is 6. 6 squared is 36. That's what we did right there. We add 36 to the left side.
You should have put that in black.
Well, then what was the point of this blue pen that you gave me?
I use that blue instead of the blue.
We've just now created a perfect square trinomial by adding 36 to the left side of this equation. But you can't just add 36 to one side of the equation without adding 36 to the other side. So we're going to have to add 36 to the right side also. Now the y terms. What number are we going to put here to create a perfect square trinomial for y? Y squared plus 4y plus what number? You take half of 4 is 2. You say to yourself, 4 divided by 2 is 2. And then 2 squared is 4. So I agree. We're going to have to stick a plus 4 there on the left side, which means we're going to have to add 4 to the right side also. We've done the hard work at this point. We can write this in center radius form now. Let's factor the x terms as a quantity squared. How do we factor x squared minus 12x plus 36? There it is. X minus 6 quantity squared, variable, sign, half of that number. I agree.
X minus half. Could you write, let's see. Write half.
Half. I'm afraid we're making it so messy it's hard to tell what's happening, but that's okay. Plus, now we have to factor the y terms as a quantity squared. Okay, variable, sign, half of that number. And what if we got on the right-hand side? We have a 24 plus 36, that's 60, plus the remaining 4, what are we getting? 64. I claim this is now in center radius form.
It's just like problem 6 and 7.
You can look there and tell me the center and the radius. What's the center?
I think they've forgotten.
Okay, that's for, we have so many little things. Variable, sign, half that number. Change sign, take the square root. So I agree, the center is at the ordered pair. Positive 6 and negative 2. What's the radius? You take the square root of that number on the right. The square root of 64 is 8.
Is that what I'm going to type in?
I don't know. What do they ask?
Oh.
No, they just say draw the graph. I mean, to draw the circle, to graph the circle.
I'm going to get it drawn before we get timed out here. Does that ever happen to y'all? 6, negative 2. So, is that right? 6.
And down 2.
Down 2.
Click. And now we need another point. So either count 8 units up, down, left, or right. We're at 6 plus 8, so you're going to what, 14? So that would be 14 negative 2.
I moved up. No, it should be right there.
Is that where he wants to be? 14 negative 2, yes.
Mm-hmm.
Save it to the original graph and check answer.
Gosh.
I think of myself as an optimist. No matter how bad the situation, I always think to myself, things could always be worse. So when they're doing these little problems like 6 and 7, okay, all we got to do is change sign, take the square root to get the center and radius. I won't complain about these problems because I think to myself, things could always be worse. It could be an expanded form, and we have to complete the square. So That makes me an optimist, I think. Some people incorrectly say it makes me a pessimist, but no, I'm an optimist. Let's do number 9. Oh, wait. Pull up that form. Pull up that little form that we have. The page.
Where is it?
It's down here. Or did you exit out? Right there.
Oh, you opened it with Edge? Why do you open it with Edge?
I opened it by clicking on it, and that
should have
was
said open with Chrome, so it would just be one of the tabs. But okay.
Okay, look, I've written out the instructions. Think about this. Center radius form. Look at this over here. Center radius form just has an x that's being squared and a y that's being squared. So when you expand that, you're just going to have an x square and a y square. You're never going to wind up with a 5x square or a 3x square. The coefficient, in order to complete the square, the coefficient for the square terms must always be 1. Notice that we went through that expansion in detail there. And the coefficient for x squared is 1. The coefficient for y squared is 1. If you have any coefficient other than 1 there, then you have to get rid of it. And the way we do that...
Step 1.
Okay, look at how I've expressed the equation. Ax squared plus ay squared. A is the coefficient of x squared and y squared. I have a c as the coefficient of x and a d as the coefficient of y and so forth. But a is representing the number in front of x squared and y squared. If a doesn't equal 1, you're going to have to divide each term by a, and that does happen somewhere along the way in the homework. We have a number in front of those x squares and y squares, and we have to divide through to get rid of that coefficient before we go on. Then you rewrite the equation by grouping the x terms together, followed by the y terms. Then isolate the constant term on the right-hand side of the equation. That's what I was doing. That's what I was doing right here. I grouped the x terms together. I grouped the y terms together. The 24 was already over on the right-hand side, but if it hadn't been, I would have moved it.
I remember I wrote this leaflet because I spent a lot of time trying to figure out how to say rewrite the equation by grouping the x terms together, followed by a blank.
I said
blank. Or
I say skip some space, and you said that looked strange. So
yeah, and so I didn't even mention going plus blank and plus blank. But why don't you go ahead and
go on? Then what did we do? We divided the coefficient of x by 2, so we squared the number that we found. That's what I was doing over on my scratch work. We take the number, divide it by 2, and then square it. So those steps,
you were down here.
It doesn't matter which one, it's just they see the pattern, divide by 2 and square it. Okay? Add that number that you find to both sides of the equation. If you're adding a number to the left side of an equation to maintain the equality, you have to add it to the right. So
that's what you did right there with the plus 36.
Then you have to repeat that process for the y's. And if you do this correctly, you should get the equation in center radius form. You should be able to factor the x terms and y terms as perfect squares and get an equation in step number 7 that looks like center radius form. And to find the center, change the sign of the number in the parentheses paired with x, change the sign of the number in the parentheses paired with y. To find the radius, you take the square root of the number on the right-hand side. And notice at the bottom, if you wind up with a net 0 on the right-hand side, taking the square root of 0, how many units are you going to move up and down, left and right?
Imagine if the circle had been 0.
If you had a radius of 0, here's your circle. You don't go up, down, left or right. So
right, that's a negative 2 to you.
So the graph is just the center point. If it's negative, well, can you take the square root of a negative number? Sure you can. It's imaginary, but it can't be expressed on a number line. And so we say if R turns out to be imaginary, then you have no graph, not even a point, and that will occur as we go through the homework. Let's do number 9.
9.
Here they have the constant on the left-hand side for us. X squared plus y squared minus 2x plus 8y minus 19 is equal to 0. Where's the sheet of paper, the list of steps?
Oh, they're over there.
What's my A value here? What's my A value? I couldn't hear you. What's my A value?
Do we have a number in front of x squared that we need to divide through by? No. You'll know it when we get to it.
That A is representing the number in front of the squares. Those numbers are both positive at this, a positive 1. So we just skip that step. Next, we group our x terms together. X squared minus 2x plus, skip some space. Group the y terms together. Y squared plus 8y plus, skip some space. The constant term you put over onto the right, so that becomes a positive 19. But I'm going to go ahead and write in my blanks here also. My black blank and my green blank. Whatever number we add here, we'll have to add to the other side of the equation. Whatever number we add beside y squared plus 8y, we'll have to add to the right-hand side of the equation as well. What number is going to go in the first blank? 1, I agree. And you take, here's your thoughts. You're thinking 2 divided by 2 is 1. 1 squared is just 1. So we add 1 to the left, and to maintain the balance, we have to add 1 to the right. What number are we going to add into the green blank? 16, I agree. You take half of 8. 8 divided by 2 is 4. 4 squared is 16. So we add 16 to the left, and we add 16 to the right. We should be able to get this in center radius form now. Let's factor the x terms. How will that factor? I'll put the parentheses in the square. You tell me what goes on the inside. X minus 1, I agree. Variable, sign, half of that number. Now the y terms, factor them. I have the parentheses in the square. What's going to go inside there? Variable, sign, half of that number. I agree with y plus 4 squared. What have we got on the right-hand side? 36. 20 plus 16, I agree with 36. Is this a circle? If it's a circle, this number must be positive. Yeah, because it has to be a positive number, so you can take the square root of it. It's a circle. What's the center? Change sign. I agree with 1, negative 4. What's the radius? The square root of 36 is 6.
And on this one, is it still, yeah, we're still graphing on this one. Eventually, it's going to get to where we just, it's asking for the center and radius, and you're typing that in. So I write 1, down 4, am I 1, negative 4? Yes. Now I need to move. I think I'm going to move 6 units up. By doing that, I'm also moving 6 units left, right, and down. Is that right? If I started at -4.
-4 plus 6 gives you +2.
Yeah. Right. And if you count it, same as moving right 6, left 6, down 6.
Any questions there? Look back at my work. Group the x terms together, skip some space. Group the y terms together, skip some space. Move the constant to the right, and you have those 2 spaces there for the x perfect square and the y perfect square. Half the number and square it to get the 1, half the number and square it to get the 16. You have to add it to both sides. Factor is a perfect square. Change sign, take the square root. I don't know about that red ink. I'm sure there's some people having trouble.
It's not
focusing.
critical. It's just arrows. Okay, this variable, that sign, half. This variable, that sign, half. Let's do number 10 now. How does number 10 differ besides the fact that it's multiple choice? I'll hide it.
They're not asking you to draw the graph. They just want you to find the center and radius. Here's the equation. 2x squared plus 2y squared plus 8x plus 16y plus 22 is equal to 0.
How does this problem differ from the one before it? Don't say, well, it's not multiple. This one's multiple choice. That's not what I mean. Here, x squared.
Show them that the handout again.
Oops, wow, this is here.
We have an a value that isn't 1. What's the a value in problem number 10? 2. You have to divide each term through by 10. That's the same, by 2. In this case, that's the same thing as multiplying by 1/2. So, but the easy way to get rid of those numbers is just divide through by them. Here, this problem is being nice to us. Everything's even, so we're not going to wind up with any fractional coefficients. But the process works even if you wind up with fractions. That'll give us an x squared plus y squared plus 8 divided by 2 is 4x plus 16 divided by 2 is 8y plus 11 equals 0.
Is number 10 now similar to number 9? They can't see your number 9, but
because you've zoomed in like that. Oh, I know. Yes, it's similar to number 9. So we group the.
Now we just start doing this. Okay.
Group the x terms together. Go ahead and zoom back in. It's easier for me to see it. We have an x squared plus 4x plus, skip some space, the y squared plus 8y plus, skip some space. And on the right hand side, what will we have? That negative 11, good. And I'm going to have a blue blank and a black blank.
It all looks black.
Yeah, it does.
Oh well.
What's going to go beside the x squared plus 4x? No. Remember, it has to be a perfect square. Okay, half of 4 is 2, and then 2 squared is 4. So you put the 4 on the left side, and you add 4 to the right side. What number is going to go beside y squared plus 8y? 16. I'm glad to hear students from my side answering. Okay. Half of 8 is 4. 4 squared is 16. My side is the quiet side. Okay. I think we can get this in factored form now. How will the x squared terms factor? I agree. Variable, sign, half of that number. X plus 2 quantity squared. Plus, how will we factor the y terms? My parentheses squared. You tell me what goes inside it. Y plus 4, I agree. Variable, sign, half of that number. What have we got on the right-hand side? Negative 11 plus 4 is a negative 7. Negative 7 plus 16 gives me a positive 9.
Well, you could think 20 minus 11.
Yeah, 20 minus 11. So what you're saying is that addition is commutative, right? Okay. Is this equation a circle?
By
Yes.
diamond, can he find the center and radius? Okay.
This number here, the fact that it's positive means it's a circle. If it's 0, all you're going to have is a point. You'll have the center point, but you can't go up, down, left, or right. If it's negative, that means you have an imaginary radius, so your circle's just some imaginary thing floating around somewhere. There's no graph. Y'all tell me the center. Negative 2, keep going. Negative 4, I agree. Change sign, change sign. Radius, 3, I agree. The square root of 9 is 3. And here's what they're looking for. They want the center typed as an ordered pair.
No, they don't. It's multiple choice.
And the radius
Multiple choice.
of 3. Oh, it is multiple choice.
Okay, so, oh wow, be careful.
Negative 2, negative 4. There's only one that has a negative 2, negative 4 center. Response B.
Wow, why couldn't they all be multiple choice? Back before y'all were born, it was.
Number 12.
Okay, we're going to...
No, let's do number 13. I want to do number 13. I like this type of multiple choice better.
Look at this. It says decide whether or not the equation has a circle as its graph. I sort of never like these instructions because it makes it sound like you're just supposed to look at it and tell.
And think about it and decide. You can't tell if this is a circle or not until you write it in center radius form.
And if that number on the right is a 0, then it's a point. If that number on the right turns out to be negative,
then they're going to be fancy and say the graph is non-existent. I'd rather they say there's no graph, but the no graph possibility is the response that says the graph is non-existent. Look at that option B. The graph is a line.
now that we can decide right on.
We can discard that immediately. Do lines have x squares and y squares in them? No. The programmer just wanted 4 options here, okay? So that you get 2 shots at entering the correct answer. If you didn't have 4 answers, you only had 1 shot to enter the correct answer. So I understand why the programmer did that. And switch to my paper. Accidentally wrote a plus 28 and called it and corrected it to a plus 26.
Oh, wow.
We group our x terms together. We have an x squared minus 2x plus, skip some space. Then we have our y terms. We have a y squared minus 10y plus, skip some space, equals, what do I have over here? A negative 26, and I'm going to be adding two additional numbers. What number's going to go beside x squared minus 2x? 1, I agree. So we put the 1 there, the 1 there.
Half and square. That's what you did. Half of 2 is 1. 1 squared is 1. Same thing over here. How do we get this blank?
What's going to go in the blank beside y squared minus 10y? Okay. You took half of 10. 10 divided by 2 is 5. 5 squared is 25. I put the 25 on the right-hand side also. Let's factor the x terms. X squared minus 2x plus 1. How will that factor? X minus 1 quantity squared. Variable, sine, half of that number, plus, let's factor the y trinomial. What's going to go inside those parentheses? Y minus 5, I agree with that. What have we got on the right-hand side? Negative 26 plus 26, I agree with 0.
Can we answer the question right now?
Is this a circle? No. What is it? It's a point. If you take the square root of 0, you get a 0. That means we even know what point it is. We know it's the point 1, 5. So you have that center point 1, 5, but you go up, down, left, right, 0. It's just a point. They don't even make you say what the point is. All they want you to do is say, when you see that the radius is 0, just a point. But we know what the point is. It's the center point, 1, 5. If you plugged in a 1 for every x and a 5 for every y, the left side would equal the right side. And that is the only point that would ever happen for.
Oops.
So we say the graph is a point. See?
If it had asked what point is it?
The center point. We can go back to number 12 now.
Oh, any questions? How did that problem differ from the ones we've been doing? The radius is just a 0, which means it's just a point. Let's go through the same steps on problem 12. Are we going to have to divide through? No, A is a 1. That's how we like it. I think there's only one problem that we have to divide through by. I think everyone has to divide through on their multiple choice problem. What number was that? 10?
10.
Problem 10?
Yeah, I think everyone there. Let me make sure I didn't miscopy that. Okay. Yeah, I think on number 10, every one of y'all is going to have to divide by whatever that number is. Maybe a 2, maybe a 3, maybe a 5. It won't be anything real big, though. At least for most people. Of course, Misty Star, she'll be dividing by 37.
And we don't know if your numbers are always like that, but that one day that your numbers were so bad.
I couldn't help but wonder if she'd said something bad about the computer, and so the computer decided to stick it to her.
I'm embarrassed to say this.
Then don't.
talking to my AI assistant, and it was asking me what my day was, and I was answering it.
What
And
your day was?
Oh, what I was going to be doing today in class. It knew I was a math teacher. And when I told him, it told me to tell y'all that and I thought it was the stupidest thing. I didn't tell it that, but I thought that when it told me this.
That's being recorded, and now she's going to watch your video and know you're talking about.
But still, she said that I should tell y'all that completing the square, the stuff we're doing right here, is nothing more than rearranging furniture in a room if you're trying to figure out the center of the room.
Does that help y'all?
I was like, what the heck is that?
I know what I'm doing, but I didn't see why that was helpful or anything. And now AI is going to come after us for us insulting it.
Well,
and you know whose fault that is?
Mine.
You with that AI assistant. You already have an assistant. Okay? You have an x squared plus a 4x. That's me.
Oh, okay. I was wondering who my assistant was.
And I'm your assistant. And at home we have a nephew that's our assistant. And a sister. We have, wait, I'm just working the problem, just going on, talking about personal stuff. Wait a minute. We got to go group the x terms together, x squared plus 4x, plus skip some space. Now we're going to group the y terms together, y squared minus 10y plus skip some space. What have I got on the right-hand side? Okay, so I have that negative 30. I pick that 30 up and move it over. And I still have those two blanks that I'm going to have to fill in also. Show me how much y'all have learned. What's going to go in the first blank? 4. 4 divided by 2 is 2. 2 squared is 4. So I put it there. Oh, what else do I need to do? Add it to the other side. Okay. What number's going to go beside the y squared minus 10y? 25, so I'll put it here. And the other side. And then we can factor. The left side will factor very nicely as x plus 2, quantity squared, I agree. Factor the y terms. What's that going to become? Y minus 5. And what have we got on the right-hand side? Look at that. That's a negative 30 plus 29. We have a negative 1. Is there going to be a graph? No graph, not even a point. Because if you plugged in the center, negative 2, 5, you're taking two numbers and squaring them. The x plus 2 is a number, squared plus squared. When you square them, what kind of numbers do you get, positive or negative? No matter what you plug in here for x, when you square it, what are you going to get? Positive plus positive. Can you go positive plus positive equals a negative? So this equation doesn't even make sense. There's no points. There are no ordered pairs that you can plug in to make the left side equal the right side. There is no graph. Y'all see what I mean when I said we're taking an algebraic approach to circles? Okay, true, we did graph them with a really nice graphing tool, but the gist of this assignment is the algebra that's involved.
You're pointing to algebra.
Oh, I'm pointing to it. Well, they can see the algebra. Just look at their own page.
Oh, okay.
And number
we've already
11.
Let's go back to 11. There.
I'm feeling like I've forgotten to say something because this is going a lot faster than I was expecting.
So just remember, you're rearranging the furniture in order to find the center of the room. I should have asked, can you explain that further to me?
You should have. You're right. So AI be thinking, this idiot, he's going to go. When I send out the nuclear pulse to take care of the people that are just, dregs on society, I'm going to send one out to that Precella household first. Okay, y'all tell me what I'm going to do. What will I do first? Group. Okay, I'm going to group the X terms together. The Y terms together. And then what am I going to do? Look at what I did the grouping. Move the 19 over to get a negative 19. Oh, and remember I have a couple of blanks I need to add in here also.
Now, once you know how to do this, you can read that little recipe and it makes more sense. But once you know how to.
Okay, so we've rearranged. So group the X terms together, Y terms together. We isolated the constant on the right-hand side. What do we do next? We have to figure out the numbers that go in these blanks. And how do we do that? Half of the coefficient of X, okay. Half of 8 is 4. And then square it. That's what steps 3 and 4 are saying. Divide the coefficient of X by 2 and square the number found in the previous step. So what number is going to go in this first blank? 16, I agree. And it has to go on the other side also, I agree. Then step 5 says, step 5 is where we're adding that number in. Step 6, repeat it for the Y's. What number is going to go in that blue, the Y blank? 4. Put it there.
Yeah.
And there.
Half and square it.
I'm just trying to show that hopefully those steps make more sense now that we've gotten the hang of it. What do we do now? Okay, we're going to factor. So factoring is that 7th step in that handout we gave you. How will the X trinomial factor? Okay, X plus 4 quantity squared. The Y trinomial? Y plus 2, good. And what have we got on the right-hand side? Negative 19 plus 20, a positive 1. Is this going to be a circle? It's positive on the right-hand side, so it will be a circle. That means you can tell me the center and the radius. What's the center? Negative 4, keep going. Negative 2, I agree. Change sign, change sign. The radius, you took the square root of that number, and that gave you a 1. Hopefully it's getting better.
Okay.
So we're looking at response B. It is a circle. The center is at negative 4, negative 2.
Make sure you put the parentheses.
And the radius is 1.
Why do you stop at 13? Is 14 review?
I don't know. I think so. Those absolute value quadratic inequalities using the cut point method.
What do? You go equal 12 equals negative 12. This is the one where there's 4 different
cut points.
And you test the intervals. Surely 15 won't be as hard. Oh, quadratic formula.
Oh, won't that stuff ever go away, Tony? What was number 4 and 5?
Oh.
Okay, let's do number 4.
Oh, they so don't want to do that, but okay.
I'm just reminding them. It's like that one day I came back from being radiated. I'd been gone for the first 8 weeks of the semester, basically. And Tony was teaching both classes, and this was all new to me. And I was like, oh, this is fun. We'd finished the class, and we had an hour left. Tony was dismissed. The class was gathering up stuff. I was like, no, we have plenty of time. Let's do more problems. And they laughed, and then they realized it. Then they realized I wasn't joking. And they didn't like me anymore. And then the pandemic hit, and we never came back to class. So just as well, since the people were so annoyed with me. So now I won't make y'all stay to do more problems.
Really well to be through after
by 4 o'clock.
Well, no, it was a morning class.
Oh, okay.
I'm
waiting. Y'all tell me what's going to go here. Do y'all remember how to do this? Okay, these were the easy problems at the beginning of class. Here, what's going to be squared? 2, okay. And then we can clean this up. Okay, that becomes an x plus 1 quantity squared. And here, y squared equals 4. Y'all remember doing this? We would plug in H, K, and R.
I'll type that in, but right now I want to mention, now, we
type
won't
this in.
Be here.
Let's wait to remind you all of that until we're through typing this in.
Oh, okay. It doesn't need to be recorded because future semesters will be
y.
Oh, no.
Not just a y squared.
I wonder if I wrote y minus 0.
They'd say no. I'm pretty sure they'd say no. We've already sort of experimented.
Equals 4.
Okay. And then how do we draw the graph? What do we do?
We say circle.
Locate the center, so that's at -1, 0.
Okay.
And then, okay, move over.
Wait, 2.
2.
The radius is 2. 1, 2.
Oh, okay.
Check it. Number 5, same thing. Okay. I'll call it quits there. Any questions about circles before we hit the stop button?
Now,